going to be, we have to understand about this enthalpy changes of in solution. Yeah, enthalpy changes in solution. Okay, is going to be energy absorbed or released when 1 mole of ionic solid dissolved in sufficient water to form a very dilute solution. Yeah. So if you have, like, for example, sodium chloride, okay, NaCl, okay, and they are solid. So when I dissolve in water, so you are going to get NaCl aqueous, or you can write them down as NaCl, okay, which is going to be solid. When you dissolve with water, they are going to give you Na plus aqueous plus Cl minus aqueous. Okay, so you can write it down that way. The only thing that we need to notice over here is going to be the enthalpy, okay, of the solution. It can be either positive or negative, okay, even though we can see that something like a formation of bond or something, but some of the situation, they do not form a proper bond, okay, with the water, okay. So not all the time, okay, they are going to form bonds, okay. So therefore, you can have positive or negative, okay. And this positive and negative has meaning, okay. If they can form bond with water, like for example, if I have a ionic compound, okay, sodium chloride and so on, when they form bond with water, okay, water is going to be very special, yeah. So they are going to have something what we call as dipole, okay, delta negative and delta positive dipoles, okay. So this is dipole, positive and negative. Okay, let me mute. Hold on. So there will be positive and negative. Okay, so please take note of that. So this one, okay, once you have, okay, this water, okay, coming to a sodium chloride. Okay, Newan, are you raising your hand to ask something?
No, sir, that's an accident.
Okay, okay. So here, okay, if you have this sodium chloride, Na plus and then Cl minus, okay, assume that they are not going to be like this, okay, assume that they are together like this. Of course, they are in a giant lattice structure, okay, that's a lot. So when they come into contact with water, okay, what happens is, okay, the water is going to be a dipole. So what happens is there will be some sort of bonding, okay, between the delta positive over here, okay. They will attract the negative ion of Cl, okay. And if I have, okay, for example, another water molecule here, this is also dipole, delta positive, delta positive, delta negative. There's some sort of attraction, okay, between the O and Na plus. So this attraction, okay, we call it as, okay, the sodium ion and Cl minus, they are called ion, okay, and then water now, because they have delta negative and delta positive, we call them as dipole. So we call it ion dipole attraction. Okay, there is an ion dipole attraction over there. So what they will do, so the ion dipole attraction will try to break the bond, okay, in the lattice, okay. So the Cl can move away, sodium Na plus can move away. So you get something where they are going to be dissolved, okay, they are going to be soluble. Okay, so if they can form a lot of bond, okay, with water molecule, of course they are going to be more soluble, okay. So if they are more soluble, of course forming bonds is going to be exothermic, so negative, okay. So that's the reason, okay, if it is soluble, okay, the enthalpy of solution must be negative, and we can still accept them if they have a small positive value, still okay lah. Okay, so they say small positive value can still be soluble, okay. But if you have a large positive enthalpy of solution, they are relatively insoluble, okay. So this one is something that you need to take note. The first thing, yeah, the first thing that you need to take note is, okay, your enthalpy of solution, okay, can be both positive or negative, okay, positive or negative. But what is the implication, okay, what is so important, what we can actually predict from this positive and negative If it's negative or small positive, then they are soluble. This is important. This is actually the summary from the slide. Okay, so if I move on, okay, you can see here, if I want to write equation to represent the solution of potassium sulfate and zinc chloride and so on, you can just see from here. Okay, it's the same thing that I've written. Okay, so I'll just move on. Now, this one, okay, I think this one also I've explained. Okay, so here, if you have lattice energy, for example, what is lattice energy? You are trying to bring, the ion, okay, closer, okay, the gases ion closer to them, each other, and you form bond. Okay, you are forming bond so that they become something like this. Okay, you are forming bond and they become like that. So let's say, for example, to form bond, you require negative 100 kilojoule. Okay, for example. And you need to, when you dissolve, like for example, now I told you, in order to dissolve, okay, this solid must be added with water and then they will become aqueous. Okay, so that is going to be this one, which is going to be the solution. Okay, but the solution, okay, normally the solution is going to be, I told you also, if it is soluble, okay, then must be a positive, a small positive only, okay, or something. But if you look over here, the data, if you look at the data, they say that in order to for NaCl, the lattice energy, that's going to be 788, negative 788. Enthalpy change of solution is only 3.9. Okay, so if you like, I give you this example, if you buy something for 100,000, of course you don't sell it for 39,000. Yeah, so there's something missing over here, which is going to be, there is the link is not completed. Okay, so there must be another one form of energy that must be involved. Okay, so that if this is 39 and this is going to be 100, there must be something, okay, which is going to be 61. Okay, 61. So what is that? Okay, what is that? So that thing is, okay, enthalpy change of hydration. Okay, so that's the missing link over there, which is going to be, once I have this gases ion coming into together, okay, gas coming together to form solid, for example, solid. Okay, so this one, okay, is going to be, when gas coming into solid, that's going to be your lattice energy. Okay, lattice energy. Then I recently, just now, okay, the first slide, we have learned that the solid, okay, that is being formed when you add aqueous, okay, with water, okay, and then that solid is going to change into aqueous. Okay, that's going to be your solution. Okay, that's going to be a solution. So there must be something that should link the gas atom, okay, and the aqueous. Okay, there must be something that links them. Okay, so that's the thing, which is going to be this one. When the gas, okay, atom, when they add with aqueous, okay, they are going to give you the aqueous. Okay, so which is going to be like, for example, you see, enthalpy change when 1 mole of specified gaseous ion dissolve in sufficient water to form a dilute solution. Okay, so it's going to be specified gaseous ion, like for example NaCl. Okay, NaCl, they will give you Na plus and then Cl minus. These are the specific gaseous ion that can be formed. Okay, so we are talking about these two ions. Okay, and these two ions, okay, they must be dissolved in sufficient water to form a very dilute solution. So how do I write the equation? Na plus gas, okay, plus aqueous, they must give you Na plus aqueous. But they don't stop over there, because normally we are dealing with two ions, positive and negative. We are dealing with two ions, positive and negative. So this one must be also positive and negative. Okay, they must be together. Okay, so it means now I have written one of it. Okay, and there should be another one, which is the Cl minus gas, okay, plus aqueous, and they will give you Cl minus aqueous. Okay, so this is the thing that you need to remember, which is going to be your hydration. Okay, one thing, okay, that you need to remember for hydration is always forming bonds with water. Okay, it's always forming bonds with water. So therefore, okay, they are always going to be exothermic. Okay, so I'll just put over there, they are always going to be exothermic. Okay, and this one, okay, you need to remember. Okay, so solution can be positive or negative. Okay, but hydration can be always must be always exothermic. Lattice energy must be always exothermic, because this part of the chapter, okay, we are dealing with three types of enthalpy, okay, which is going to be lattice energy, solution, and hydration. Okay, remember we have divided this chapter like into parts. Okay, the first part we learn about this Born-Haber cycle. So many components there. Okay, when you put into formation, okay, you are looking into ionization energy, atomization, okay, and you're looking into electron affinity, okay, and then lattice energy and so on. So many components over there in the first part. But for this second part, we are only going to deal with three situations, which is going to be your hydration, solution, and lattice energy. Okay, so this one, when we look into this enthalpy change of hydration, okay, they have also written over there more exothermic, okay, when smaller ionic radii and larger charge. This one we have learned yesterday. I told you when any situation when you have a smaller ionic radii, this charge is going to be spread at the smaller volume. Okay, when they are spread at smaller volume, they become like some sort of very strong positive. Okay, or the concept that we look into is going to be what we call as charge density. Okay, if we forgot about this concept yesterday. Okay, charge density, okay, is going to be charge over volume. Okay, so if you have charge over volume, if you have a smaller ionic radii, okay, so your volume, okay, is smaller. Okay, so the volume is smaller. Okay, so when volume is smaller, okay, your charge density is more. Okay, so when the charge density is more, okay, it means your ion, okay, will form a stronger bond, okay, with another ion. Okay, so if they can form a stronger bond with another ion, of course they are going to become bond forming is more. Okay, so it means they are going to be more exothermic. Okay, or if you want to just look into the the negative or positive, okay, so of course they are going to be negative. If form more, okay, so it means they are going to be more negative. Okay, so similar to the earlier one. Okay, so what I'll do, I'll skip all the way down, okay, because this is a similar concept also. Okay, you see here, change of hydration enthalpy, enthalpy of hydration down the group. Okay, since we are already started with this charge density, you see down the group, okay, I also told you down the group, okay, the size is increasing. Why? Okay, despite the increase of proton, okay, you have more distance and more number of shells. Okay, and this distance and number of shells, okay, they are going to outweigh the increase in proton. Okay, when they outweigh the increase in proton, okay, so it means that you can just say that your charge density is getting lower. Okay, why the charge density is getting lower? So if you cannot remember, you just put the charge divided by volume. Okay, now your volume is getting bigger. Okay, so your same charge, okay, so the value, okay, is going to become smaller. Okay, so the charge density is going down. So if it is charge density going down, it means this is going to be more positive compared to this one. Okay, so if you have another ion, okay, for example Cl minus and so on, so if I have Cl minus here, okay, and Cl minus here, which one, okay, will form a stronger bonding? Okay, of course they are going to form bonding more over here. So in this case, this is not negative ion because it's hydration, so we are talking about the negative ion from the water, for example. Okay, so So they are forming bond, okay, with the water. Okay, I just use AQ. So if you have AQ over here, okay, so this one will form a better bond with water. Okay, so if they form a better bond with water, okay, this is going to be more exothermic. This is going to be less exothermic. Okay, so you can see as you go down, I written over there decreases. Okay, but it will be better if you say that they will become less exothermic. Okay, or if you want to show, because enthalpy of hydration is always negative. So if you go down, okay, you can say they will become less negative. So that is also fine. Okay, this is required. Yeah, this is required. So this one is similar to your electron affinity. Yeah, similar to that. But now, okay, we just come back to our main part, okay, which is going to be the relationship between them. Yeah, the relationship between them. This one I've done yesterday. Okay, you can just did I do this yesterday, Ashley? No.
I don't recall 13B,
Okay.
so
Okay, so this one is the one that I did with the other class. Okay, but it's okay. You see here, okay, why is the enthalpy change of hydration? Okay, it's always exothermic. Okay, why is always exothermic? Because it's always involved the formation of bond with water. Yeah, and then write the equations to represent the hydration of sodium ion. Okay, so sodium ion Na plus hydration. Yeah, so it must be gas plus AQ, okay, to give you Na plus and aqueous. Okay, so something like that. Okay, hydration of chloride ion, similar, Cl minus gas plus AQ to give you Cl minus AQ. Okay, so draw diagrams to show 4 molecules hydrating a magnesium ion. You can see the diagram over here. Okay, Mg2 plus is a positive ion, so you see it's surrounded by negative. Okay, so that is going to be the diagram that you can draw. Okay, 2 molecules hydrating a bromide ion negative, so you can see the positive. Okay, here. So this one, when they ask you to draw. Okay, now explain why enthalpy change of hydration of magnesium ion is more exothermic than hydration of potassium ion. So magnesium is 2 plus, potassium is K plus. Okay, so why magnesium 2 plus is more exothermic? Okay, so quite see, you have to refer to your charge density. Okay, Mg has 2 plus, okay, which is going to be more charge. Okay, so the charge density is more. Okay, because of that, okay, they are able to form better bonds, okay, with water. Okay, and this is going to make, okay, the value, okay, to become more exothermic. They will release more energy. Okay, that's the explanation. And then here, name changes associated with the equations. Okay, if you know all the definitions and so on, you should be able to come up with the definition or changes immediately. Yeah, like for example, if you have solid, okay, dissolved in water. Okay, this is the first one that we have learned, which is your solution, enthalpy change of solution. If you have potassium ion in gas and then they become into aqueous, this is the one that we just learned, okay, which is going to be your hydration. Okay, hydration. And if you have gas and gas ion, okay, to form solid, then it's lattice energy. And if you have gas ion, okay, and then plus with AQ, then automatically you should know it's hydration. Okay, so this one you need to learn, okay, how to get it done and so on. You can just go through all this, okay, go through all this, okay. And let's actually focus on the calculation. Okay, I think this one I started already. Actually, maybe I didn't go through in detail. I remember when last time Mr. Rufus came, and then I ended up with I'll say let your soul go and hide, and then finish the lesson. Yeah. So this one, okay. If you look at this relationship between them, okay, I told you everything can be joined together. So if you look into, okay, into the gaseous ion. Yeah, so if you have this ion, like say for example Na plus, okay, and the Cl minus, they are gaseous ion, and you are going to form, okay, NaCl, which is going to be solid. Okay, this is going to be, I think everyone should know this already, which is going to be your lattice energy. Okay, your lattice energy. And then, okay, we also learn in the beginning the solution. Okay, the solution is going to be when you have, okay, solid, okay, plus with aqueous, okay, you are going to get NaCl, which is going to be aqueous. And this NaCl aqueous, you can also write it down as Na plus aqueous plus Cl minus aqueous is still the same. Okay, still the same. And the last one that we have learned today is going to be how do we combine this link, okay, which is going to be the gas is going to form this, okay, which is going to be your hydration. So this is going to be, you add AQ, okay, so this one, if I just put this is lattice energy, so this is going to be hydration. And what is this? This is solution. Okay, from this, okay, you will come up with this equation. Okay, what is the equation? Clockwise equals to anti-clockwise. Okay, you see anti-clockwise. Okay, clockwise. Okay, lattice energy clockwise. Okay, solution is clockwise. Hydration is anti-clockwise. So I can just say hydration, okay, equals to lattice energy plus solution. Okay, or okay, if you want to remember, okay, I think some people they memorize things differently. Yeah, so this one, if you want to derive, you can derive directly if you can get this. Okay, or if you can cannot remember, so you just remember let, okay, let your soul go. Okay, so it means let it go. Okay, when you let it go, so they go over there, so it's minus if you let go. Okay, you let go. And height, okay, and height. Okay, so this is going to be if you want to remember. Okay, but to test whether it's correct or not, lattice energy, if you bring a solution over here, hydration minus solution. Yeah, hydration minus solution. Okay, so up to you how you want to remember. Okay, but okay, I will also tell you, okay, this one, okay, to remember this, let your soul go and hide and so on, it will be only useful at the beginning, okay, only at the beginning. Okay, when you begin, you don't know how to solve and so on, I will suggest you to memorize the formula, okay. But as you progress, okay, you will notice that, okay, this one is not really required. You don't even need it. Okay, you don't even need it. Okay, because okay, as you progress over here, I will strongly advise you to use this method. Okay, which is going to be the Born-Haber cycle, and you will notice that you can derive the formula directly from the working. I'll show you how you can derive the formula directly from the working. There are two calculations that I've shown over here. If you just look and compare, okay, you see, yeah, lattice energy is always negative, okay, and hydration is always negative. Okay, what you notice over here is the hydration went all the way down, okay, all the way down. Lattice energy also go all the way down. Solution can be positive, can be negative. Okay, but what you can see over here is your lattice energy plus solution is the same as your hydration. Okay, so this diagram is actually telling you about this formula. Okay, if you can relate that. Okay, even you can see here. Yeah.
In a regular born paper, the we won't have hydration and like solution, right? It
No,
usually is
no, no.
just like loss energy.
Yeah. If they are testing on the hydration and solution, it will be a separate question. If they are testing on the lattice energy and the other Bornhaber, it will be on separate question. So they will not test both of the concept together. Okay, so later when we do some revision, you will see. Okay, whenever they say define enthalpy of hydration, so most of the time, if they start the question like that, they are not going to talk about the typical Bornhaber. They will talk about this calculation about hydration, solution, and lattice energy. So you no need to worry that you need to extend this, okay, to your previous Bornhaber. Okay, it will not be combined. Okay, unless they put it as a like a small part of the question. Yeah, then they can still ask like that. But you no need to combine both of them. Yeah. Now, even here you can see hydration. Okay, is going to be lattice energy plus solution. But how do we get all this? Okay, in order to understand this better, maybe we start to draw something over here. Okay, I'll try to show you over here. Now, it's the same, okay, if you have lattice energy, okay, like for example, since just now, you can see that that's something like a right and left, yeah. So on the right just now, you saw hydration. On the left, you saw your lattice energy and your solution, okay. But let's say we try to just simply draw, okay. You see, if it is hydration, okay, and then lattice energy, so it's all coming down. So it means now maybe we start at the top, okay, which is going to be your Mg. Let's say I'm talking about magnesium, maybe sodium chloride. I think way more easier to write. So if let's say I'm talking about Na plus gas and then Cl minus gas. Okay, why I start from there? Because hydration start from Na plus gas and Cl minus gas. Lattice energy, it is also starts from Na plus gas to Cl minus gas. Okay, so that's the reason why I put them at the top. And okay, when you look at lattice energy, for example, lattice energy will come like you are going to get NaCl solid. Okay, this one is going to be from here. So now if I want to show this, okay, from here to here, this is my lattice energy. Everyone should know this. Okay, so the next is, okay, when I have this NaCl solid, okay, and then I dissolve in water, okay, and then assume, okay, this one is going to be soluble, because I think everyone should know also sodium chloride is soluble. So if they are soluble, then solution is going to be negative. So I just put, okay, dissolve in water, and I'm going to get NaCl, which is going to be aqueous. Now, if you look at to the right, okay, hydration. What is hydration? This gaseous ion is going to change into NaCl aqueous also. So you can extend this line all the way to the right, and you can just put from here to here, which is going to be your hydration. And now you can ignore this center line. This is how you draw that line. Yeah, hydration is going to be same as lattice energy plus your solution. Okay, so this one, if you are good at this, you will remember that formula already by heart. Okay, I remember this way already because I don't use that let your soul go and hide, because I think if you want to use that in the beginning, it's okay. Okay, but if you are already know about this one will really help you to understand things more better. Okay, which is hydration equals to lattice energy plus solution. Now, I'll give you one more example. What happens, okay, what happens if your enthalpy of solution is positive? Okay, I think this one is not shown in the previous two examples that I shared to you just now. Okay, what happens if it is positive? Okay, let's actually see what will happen. You are always going to start, okay, with let's say now I'm talking about, let's say maybe MgCl2, for example. Yeah, MgCl2. Okay, So Mg2 plus, okay, which is gas, okay, plus 2Cl minus, which is going to be also gas. And when I join this together, okay, of course, we are going to have lattice energy, which is going to be to form magnesium chloride solid. Okay, this is going to be my lattice energy. And then, okay, I told you that the enthalpy of solution is positive. Okay, enthalpy of solution is positive. If my enthalpy of solution is positive, of course, don't go and put it down. Okay, that is going to be exothermic. Okay, so what you can do now is going to be positive. So I put another line at the middle. Okay, I hope you're still with me. Okay, it's not in the textbook. Okay, it's not in my notes just now. Yeah, so now it's going to be positive, which is going to be you are going to form Mg, okay, Cl, which is aqueous, because MgCl solid plus aqueous to give you MgCl aqueous. Yeah, so this is going to be positive. Okay, I put over here. Now, my question over here is, okay, you see, from here to here, okay, this is your lattice energy. Okay, now, if this is going to be your solution, my question over here is, where the arrow from here supposed to stop? Position number 1 or position number 2? Hydration. Jordan. Follow the definition. What is hydration? Erlin, you want to answer that?
It should stop at the MgCl aqueous.
Yes, correct. Okay, because according to the definition, it's supposed to be the gaseous ion up to the aqueous. Yeah, so it will stop here. Okay, this is already like you are analyzing stuff more. Yeah, so you see here when you have this situation, okay, what happens over here is it is still going to follow, okay, the same equation, which is hydration is, okay, I'll give you a value, okay, so that we can really see this. Okay, let's say your lattice energy is a negative value, but I'll just give a number. Okay, negative 100, for example. This one is negative 100, negative 100, and the solution is a positive value. So let's say we take it as positive 40. Okay, positive 40. Now, when I join this lattice energy plus solution, okay, so Clienta, lattice energy plus solution, what is the value? Negative 100 plus 40. What is the value?
Negative 60.
Yeah, so it means that negative 60, I hope you agree with me that this one from here to here is negative 60. Okay, so this negative 60, we get it from where? Lattice energy plus your solution. Okay, which is going to be negative 100 plus 40, which is negative 60. Now, this value stops over here, negative 60, and this is also negative 60. Okay, so what does it mean? Your hydration is lattice energy plus solution. Okay, this is very, very important. So you if you look into this this part, okay, when I was teaching you this part just now, okay, even though there are two examples, okay, that are showing about negative the exothermic of this enthalpy of solution, okay, even though you can say, okay, all the way down, okay, they are going all the way down, okay, until here, okay, and then they are going to form hydration. Okay, and then this one is going to be plus with this. How if, okay, it's going to be enthalpy of solution is positive? How do I draw? Okay, how do I represent? Okay, if that is your question, okay, the answer for that question is here. Okay, so I already thought about it and I explained to you also. Okay, the equation is still the same, but you don't draw all the way down. Okay, you don't draw all the way down. How to really follow this up? Okay, then you have to refer to your definition. Okay, so the definition will really help you. Yeah. So if you look at the other parts, they're very simple. Okay. If I didn't focus on this part and so on, the reason is you can use the formula just like that and then you get the answer. Okay. How? This one plus this one. Okay. 506 and 406 negative 912, for example. Okay. If this is negative 912 and this is negative 902, what is this? Negative 10. As simple as that. Okay, so you can get it directly from here. I suggest to use this method. Okay, but if you still not sure, okay, you can still use this method. Okay, this method is very important as well. Okay, do remember, don't this one I already draw to you for you earlier. Okay, this method is also important because they will ask you to draw. Okay, so this one is important. But when calculation, you want to use this first method, second method, or you want to use let your soul go and hide this formula directly. Yeah, up to you. Okay, up to you. Okay, but I strongly suggest you to learn this method. Yeah, so visualize. Okay, visualize hydration on the right, lattice energy, and your solution on the left. Okay, so you need to remember that. Okay, so the same thing applies here. Okay, you see the hydration. They give you the hydration of Li plus. They didn't give you the hydration of Cl minus. They have to be added together. Okay, so you have the lattice energy, you have the solution. Okay, this one plus this one. Okay, let's say that is going to be negative 883. Okay, so this one plus A must be also negative 883. So you can just find what is A. Okay, and you will get negative 364. Yeah, so this is going to be easier. Okay, easier if you use the second method or this method. Yeah, please remember how to use. Okay, so this one they showed using the cycle. Why this is also important? Because they will ask you to draw enthalpy cycle. If cycle, you don't draw this one. Okay, you draw this type. Okay, so if cycle, draw that, and then they ask you to calculate. Of course, they ask you to draw, so it means they want you to use this method. But if you don't want to use that method, also fine. Okay, we know that hydration. Okay, negative 364. If you put it in your mind, yeah, on the right, negative 364. So Mg2 plus, I don't know, so I just put plus A. On my left, okay, must have my lattice energy 2592. Okay, and my solution is negative, so plus, okay, the solution negative 55. Okay, and I can get what is A. Okay, this is, okay, when you just use the imagination. Okay, you just use the left and right. Okay, and you can also get, and you can skip all this part. Okay, but be very careful, don't simply skip. Okay, you will make mistakes like what I did over here. Okay, because, okay, you need to also consider the hydration for Cl minus. You have 2 Cl. Okay, you have 2 Cl. Okay, so I don't straight away follow. Okay, because MgCl2, okay, they have, okay, Mg2 plus and then 2 Cl minus gas. Okay, so you need to also consider that situation. Okay, when you use the hydration. So when you are using hydration, you are using 2 Cl minus. Okay, 2 Cl minus. So I need to still times this by 2. Okay, I still need to times by 2. And then the lattice energy, no problem, no need to times by 2. Okay, the solution also no need to times by 2. So the only problem, I think the only thing that you need to be careful is the times by 2. Yeah, that's why I think here, okay, you see, if you don't times by 2, you will make a mistake. Okay, so this one take time. Okay, learn, and then take time, and then try to get used to this. Okay, but overall, okay, if you look at it, we have completed the part that I want to cover. But there is another, before we end the week, I want to also introduce entropy. So I will actually start with the new part also tomorrow. Okay, because this one, if you look into our syllabus, okay, there are 4 subtopics. Okay, so we have covered 2 subtopics. Okay, so before our AS, we will try to cover another one more subtopic. Okay, so after your AS, okay, then we will continue with the last subtopic. Yeah. So that's it for today. Okay. If you have any questions, maybe it's already too late. Okay, you can ask me through WhatsApp. Yeah. I will repeat this also again next class so that you can just prepare yourself. Okay. If you have any question, you can ask me next class. Okay. See you guys. Bye.
Okay, bye, sir.
Bye,
Thank
sir.
you.
Thank you,
Thank you,
sir.
sir.
Bye.
Yes.
See you tomorrow.
Bye, sir.